Right. Okay, we are going with DPP 1 beta. DPP 1. This is question number 10. Question number 10, center of mass. Okay. You see, more than one choice type. This is more than one choice type. He has provided you 4 options. In that, you may get more than one option here, right? What he gave in the question: a block of mass m slides down an inclined plane. This is small m slides down an inclined plane of a wedge of same mass m. Okay, friction is absent everywhere. Which of the following statements is correct? You see, beta, this wedge is fixed or not fixed?
Not fixed.
Not fixed. Okay, this is a block, and all the surfaces are smooth. Okay, so we can't expect friction. Okay, for the friction to exist, what are the conditions? N should not be 0, N is non-zero, mu is non-zero, and tendency to move. Okay, it may have tendency to move, but what happens? Mu is 0. So which condition is failed? Mu is 0. Okay, so friction doesn't exist here. He said smooth surfaces. Okay, this is ideal condition. What he specified. Okay, now he gave some options. Vertical component of acceleration of block is, this is the block, this is the wedge. Vertical component of this block is g cos square theta upon 1 plus sin square theta downward. This is with respect to which observer? Ground observer. The first option is asking with respect to which observer? Ground observer. And second, acceleration of center of mass of a block plus wedge is g sin square theta upon 1 plus sin square theta upon 1 plus sin square theta downwards. Okay, is it clear? So next is acceleration of center of mass of the block wedge system is g cos theta upon 1 plus sin square theta downward. All these are what? Acceleration of center of mass of this block and wedge system is asking in which plane? Ground plane. Yes, acceleration of center of mass. Center of mass of which system? Block and wedge. They are considered as system. So the contact force between block and wedge will become internal force or external force? Internal forces. So vertical component of acceleration of the block is 2g sin square theta upon 1 plus sin square theta downward. The vertical component of acceleration of the block is giving 2 conditions, option A and option D. Okay, same vertical component of acceleration of the block. So which of these options are right, he is asking. Okay, first of all, let us try to evaluate the center of mass of this block and wedge system. Block and wedge system. Okay, we can work out this session from in both the frames. Non-inertial frame, that is with the wedge, with respect to wedge frame, we can work out, we can use that ideas also. Otherwise, directly from ground frame, we can analyze by taking wedge constant. What constant? Wedge constant. Okay, wedge constant. Is it clear? Now, this is information given in the question. We shall go with that things. Okay, right. Right. You see, this is a ground observer. Both are mobile. Nothing is fixed here. Small m, that is block, is moving on wedge. Wedge is also moving. Why wedge moves? Can you say? Wedge is applying a contact force n like this. It has component na, n horizontal component parallel to earth. Yes or no? So because of this contact force on this wedge, and nothing is to counterbalance this n parallel component acting on wedge. Nothing is there to balance this. Okay, that's why wedge starts moving towards left. Under what force? Component of contact force applied by small block on wedge. It starts moving. Yes or no? Any other horizontal force can you expect on the wedge? You can't expect. So this wedge starts accelerating towards left. Is it clear or not? You see, this is n on the wedge. Okay, one more force on the wedge is mg. Okay, and other force on the wedge is n1. N1 is nothing but contact force on the wedge by the earth surface. Okay, and this is n. If this is theta, this is also theta. If this becomes 90 minus theta. So this will become n sin theta. N, this is 90 minus theta. This is theta. This is n cos theta, this is n sin theta. So on the wedge, along horizontal direction, how many forces are acting? Only n sin theta. On the wedge you can expect. You are able to understand? You are able to understand the things. So what is this gravitational force? Weight of the wedge. And what is this? N1. The contact force applied by the earth surface on the wedge. So on the wedge, vertically how many forces are acting? N1, Mg and N cos theta. What Nana? N cos theta. So on the wedge, if you draw free body diagram, what is going to happen? Wedge, free body diagram of wedge. What you can get? N1 is upward. Okay. N cos theta is downward plus Mg. N1 is upward, N cos theta is downward and Mg is also downward. So N cos theta plus Mg. Okay, this is one of the relations. Okay, who is observer here? Ground observer. Yes, he is drawing this free body diagram and is applying Newton's second law along y direction. Okay, as this wedge has no motion along y direction. Okay, upward forces should be balanced with downward forces. This is about wedge. What I said? Wedge. Is it clear or not? You are able to understand? Now, suppose this wedge is accelerating towards left with acceleration A. What a? Acceleration A. Who is the observer here? Ground observer. With acceleration A. Wedge is moving towards left. Under which force? N sin theta. So horizontally on the wedge, how many forces are acting? Only N sin theta. Any horizontal force is there? Any forces horizontally? Can you expect any forces horizontally on the wedge? No. Only N sin theta. You see beta. Observe carefully. You see, this is N. Applied by whom? Block. This block is there now. It is applied contact force on this. On this block also, wedge will apply N. So this is N. Its horizontal component is N sin theta. As this is theta. This is also theta. N sin theta is acting on the wedge towards left. Any horizontal force can you expect? Actually on the wedge how many forces are acting? Two contact forces. One is Mg. One contact force is vertical. Other contact force is oblique. That's why we are able to get an horizontal component. What about Mg? It has any component horizontally? No, because it is purely vertical. So on the wedge can you expect any horizontal forces other than n sin theta? No. The only n sin theta unbalanced force. Because of under this unbalanced condition, this wedge starts accelerating towards left. Suppose let us take this acceleration as A. With respect to which observer? Ground observer. Okay? This is with respect to our observer, ground observer or favorite observer. Okay? Right. Now, how I can write now? N sin theta is equals NA. This is equation 1, this is equation 2. Is it clear or not? Any doubt in this? Now, a ground observer is observing wedge, block. What Nana? Block. A ground observer is observing block, not wedge. Okay? He is a ground observer. As per his observation about the wedge, this is the things. He derived this. Ground observer's observation on the wedge is this. Ground observer's observation on the block is how much? How he observes? Let us see once. You see, the wedge is like this. This dotted line is the next position of the wedge. At t is equal 0, this is the dark lines, the wedge you can see. Okay? And after some time the wedge shifted here and the block shifted down. Means actually for the ground observer what he feels, block is moving along the inclined surface or some other inclination. Some other inclination. You see, when the wedge is here, the block is here. When the wedge shifted here, block will come down or not. So block is not moving along the inclined plane direction. Okay? The block is not moving along the inclined plane direction. Yes? It is moving in some other direction. With respect to which observer? Sure. Yes. Clear. And one very important observation by the ground observer. So he can't analyze easily about blocks. Yeah. Okay. Clear. But one observation he can do. What observation is? This block M is moving on this wedge without losing contact. This is guaranteed by ground observer. Okay, without losing any contact. Is it clear? Means Without losing contact means, what is the constraint here? Wedge constraint we can use. Without losing contact, two objects are moving means, at the contact surface you draw the perpendicular to the contact surface. Along that perpendicular direction, can we expect different velocities for the objects? Different accelerations can you expect at least? No. You see, what is the contact surface here? This is the contact surface. This is the contact surface. Let us see once. This is wedge. This is theta. This is contact surface. Draw a perpendicular to the contact surface. Draw a perpendicular to the contact surface. Okay, what wedge constant says already we learned. Yes, along this perpendicular direction, the wedge end block should have same velocities, otherwise relative velocity of wedge end block should be zero. Means same velocities. And accelerations also should be same. If that doesn't satisfy, if it is not satisfying that condition, relative velocity is zero and relative acceleration also should be zero. If that condition is not satisfied, what happens to this contact? They will lose the contact. But practically they are not losing the contact. From which observer? Ground observer. That is your inertial observer. Okay? Right. Now, what happens? You see, the wedge has acceleration A in this direction. In this direction. Sure? Now, this block also should have, yes, this wedge has acceleration A in this direction. You draw a perpendicular like this. To this surface, this is perpendicular. Okay? If this is theta, what is this beta? Theta. What is this beta? What is this? Theta. So now you can say, this is A, this is A, this is theta. Okay? A cos theta, this is A sin theta. This is A cos theta, this is A sin theta. What is A sin theta? Acceleration of the wedge along which direction? Perpendicular. Along this perpendicular line. Okay? And what about this block? What acceleration it should have along this direction? Same A sin theta. Yes or no? By which constraint? Wedge constraint. Okay? So ground observer, what he feels about small m means, its acceleration along this direction is what? A sin theta. So block's acceleration, small m block's acceleration along this direction is A sin theta. Okay? This is from which observation? Ground observation. Okay? Now you take this as, what are the forces on m? N and mg. Okay, what is this? mg cos theta. Now what is the feeling of ground observer? This m is having acceleration A sin theta in which direction? In this direction. Okay, and what are the forces in this direction as observed by the ground observer? mg cos theta and n that side. So what he will write? mg cos theta minus n is equals m times A sin theta. Okay. So what you will write about the block? mg cos theta minus n is equals m into A sin theta. M into A sin theta. So you will get one relation here. mg cos theta is equals n plus ma sin theta. This is equation number 3. Is it clear or not? Issue is so simple. No? Now, why we are doing all these things? Yes? Why we are doing all these things? To find the acceleration of center of mass. Okay? Right. Acceleration of center of mass we are supposed to find. Okay? So, acceleration of center of mass is given as what? F net external is equals mass of the system times acceleration of center of mass. F net external on the system is how much? F net external on the system is what? You see, this block and wedge is a system. Okay? The contact force between this block and wedge N is what? Internal force. Obviously, F external is equal to M times ACOF. I proved it. Okay? So what are the external forces on this block and wedge system, anyone? Gravitational force. Earth is not the system here, part of the system. Earth is external. So whatever the force Earth applied is external. Okay? So smaller block and wedge system. Okay? The contact force between them will become internal force. Okay? So what is external now? Gravitational force. On this and this gravitational force will be there now. Not only that, Earth is applying N1 upward. That is also a external, because Earth is external for these two systems, these two block and wedge system. Block and wedge together is a system. Earth is not included in the system here. So whatever the forces Earth apply on these blocks is external force. So mg is downward for both of them. 2mg downward and N1 upward. So what is the net external force acting on it? What is the net external force? Acceleration of center of mass is given by F net external upon total mass of the system. Mass of system. So what you are going to get here? Yes, F net external is what? 2mg minus J cap. mg of wedge, mg of block. N1 J cap. And mass of the system is what? 2m. So I want acceleration of center of mass means I need to calculate what? N1, because given are m and g are given. N1 I should calculate. N1 to calculate I am going to use these equations. You get N1. Theta is given. Theta is given. So to get N1, what is the N? We need N. We need N value. So we should get N value here. Yes. How to get N value? Yes. Yeah. N is equals. Yeah. N is equal to MA upon. No, those things. You see, beta. You replace MA with N sin theta here. You make N common. You will get directly N value or not? From equation 3. From equation 3, what we are going to get? From equation 3, what we are going to get? From equation 3. From equation 3 and 2 and 3. So I am replacing MA with N sin theta. So what I get? mg cos theta is equals N times 1 plus sin square theta. Issue is simple. So N is equals to what, beta? mg cos theta upon 1 plus sin square theta. Issue is so simple. We got N now. Clear? We should substitute that N here. Yes? So what we get? What we get? N1. Yes? What, Nana? N1. Clear? Any doubt in this calculation process? Sure? So we will get N1 if we replace N with this value. So what we are going to get N1 value? N is nothing but mg cos theta. So mg cos square theta upon 1 plus sin square theta. You are able to get the point. So I am going to get N1. Okay? So this is equation 4 I am saying. From equation 1 and 4. From equation 1 and 4. So what I am going to get from equation 1 and 4? From equation 1 and 4, what I am going to get? 1 and 4. What is N1 value? mg cos square theta upon 1 plus sin square theta plus mg. So what are you going to get then? Yes? 1 plus mg common ले सकते ना? Yes. So what we will get? 2 upon 1 plus sin square. We are right? N1 is what? 2mg upon 1 plus sin square. This is N1. Okay? So we should replace with N1 with this 2mg upon 1 plus sin square. So what we are going to get then? Acceleration of center of mass. So acceleration of center of mass is nothing but what you will take? 2mg minus j common ले लो. 2mg minus n1. So what you will get? 2mg minus 2mg upon 1 plus sine square theta. Minus j cap. So what you are going to get? 2mg कॉमन ले लो. 2mg कॉमन लेने से क्या निकलते हैं? 1 plus sin square theta minus 1. What you are going to get? Sin square theta upon 1 plus sin square theta. This is what? Minus j cap. What is this? Yes, upon 2m na. This is upon 2m. Upon 2m. What you will get? 2m. Yes. So what is the acceleration of center of mass? Acceleration of center of mass is g sine square theta upon 1 plus sine square theta minus j. Is it clear? So what you can see options? Yeah. So what is the acceleration of center of mass is? How much we got? G sine square theta upon 1 plus sine square theta. Is it clear or not? So this is the situation. Okay, beta. So what is this option? D. Option D. One should stand and say. What is the option, beta? B. Yes. 6. Okay. Now option B is right. Okay. And he is asking about what? Block's acceleration also. Na? Whatever it may be. Block's acceleration or not that is. Block's acceleration with respect to which frame he is asking? Ground frame. Okay. With respect to ground frame. Right. Let us see that once. Let us see that. Okay. Yeah, that is it. Right, let us see. So what is the option given? You see, Nana, what we got? Acceleration of the block plus center of mass of acceleration of center of mass of block plus weight system. How much we got? G sine square theta. G sine square theta. Yeah. G sine square theta upon 1 plus sine square theta downward. Minus j cap we got na? Because our x-axis is horizontal, y-axis is vertically up. Okay? Right. And he is asking about what? Acceleration of the block. Okay, it may be vertical or horizontal component it may be. But we are supposed to find acceleration of the block with respect to which frame? Ground frame. See. You see now. Let us go for that. Acceleration of the block. Can I clear these things? Sure? You wrote now. Yeah. Now coming to the points. Let us go for acceleration of the block. Acceleration of the block with respect to center of mass is nothing but what we will get? Acceleration of the block minus acceleration of mass. Okay. Acceleration of the block is asking height. Yes. How we can get acceleration of the block with respect to center of mass? Yes. अरे यार, आपके पास पूरा ब्लॉक और स्विच का सेंटर ऑफ मास है आपके पास, आइसोलेशन. Acceleration of center of mass is given by m1 a1 bar plus m2 a2 bar upon m1 plus m2. a1 bar wedge का ले लो, कितना है वो? a minus I का. a is there, a you can find from there. a is there or not? Can't we find a here? We got n now. Can't we get a? Yes, we can. Clear? a minus I cap is there, a1. What is a2? Acceleration of the block. Can't we get from that relation? Yes, we can get. Not only vertical, horizontal component भी निकल सकते. Okay? So, you see, this is the situation. Right. Now, we shall go with the things now. We have acceleration of center of mass in our hands now. Okay? Right. Acceleration of center of mass is given upon mass of wedge, acceleration of wedge plus mass of block plus acceleration of block upon mass of wedge plus mass of block. From this, can't you make AB as a subject? Acceleration of the block. You have AW, acceleration of the wedge, as A minus I cap. Can't you find A minus I cap from that? How to find n? How much we got n value? N value how much we got? Mg cos theta upon 1 plus sin theta. So from this what we got, n value is available now here. N value is available here. Mg cos theta upon 1 plus sin square theta. Okay. If you substitute n value, can't you get m? How much can you say? N is equals A is equals g cos theta sin theta upon 1 plus sin square theta. Sure. From this we can get or not? From 4 and 2. From 2 and 4 can't we get A? Yes, we can get A. So we got A as what? Yes, g cos theta sin theta upon 1 plus sin square theta. Yes. So that is the situation. Now we have AW. Yes, acceleration of center of mass also. How much we got? G sin square theta 1 plus sin square theta. Yes. So can't we make AB as a subject here? Acceleration of the block. How much? This is m plus m, 2m. This is m. What we will get here? 2. m common ले लो. 2 निकलते. 2 times acceleration of center of mass minus गया. m गया थे ना? What is that? Acceleration of the wedge. So we are going to get acceleration of the block. Okay, with respect to ground earth. Okay, right. For that, 2 times acceleration of center of mass is what we done? Yeah. What we are going to get? G sin square theta upon 1 plus sin square theta minus j cap. Minus acceleration of wedge is what? G cos theta sin theta upon 1 plus sin square theta minus I cap. Yes or no? So what you are going to get then? Yes? Can't you solve this? How much you are going to get? Please.
Vertical component.
Yeah, vertical component is available here. How much it is? 2g sin square theta upon 1 plus sin square theta. What is horizontal component?
G cos theta sin theta upon 1 plus sin square theta.
Very good. You see, our estimation came right. Acceleration of the block has horizontal component along positive x-axis and vertical component along negative y-axis. You take minus of minus is what? Plus. So this block has horizontal component. How much? This is acceleration of the block AB. It is not along inclined plane, you see. Okay. How much we got? This has AB horizontal. How much? G cos theta sin theta upon 1 plus sin square. Minus of minus is plus. And one more component is y component. Negative y direction. You see. 2g sin square theta 1 plus sin square theta minus j cap. You see how we analyze the situation. Okay. So what is the one more option available here with us? D. What is that?